All right, so we have the situation of this kid pushing this cart, and once again, always start with the free body diagram. Do not deviate from that idea. Always a free body diagram. And let's label the forces. So we're going to have the pushing force, we're going to have friction, we're going to have the force of gravity, also known as the weight, and we're going to have the normal force. Now, we want to know the coefficient of friction between the tires and the lawn, so that means we actually have to figure out a couple of things. First of all, let's note that in the x direction, the pushing force completely balances the friction force. And in the y direction, the normal force completely balances the force of gravity. And this actually lets us get started on figuring out a couple of things, because ultimately we're going to use the fact that friction is mu times n. So using the fact that the pushing force is 180 and only friction balances the pushing force, that tells us friction is 180 newtons as well. Similarly, let's get the force of gravity acting. That's going to be 15, and I'm going to do something. I'm going to round 9.8 to about 10. And so this is going to give us 150 newtons when we calculate. Similarly, in the y direction, the normal force balances the force of gravity. So we're going to be left with the normal force being 150 newtons as well. So when we plug this into our equation, we're going to end up getting 180 is mu times 150, and that gives us mu equal to about 1.2. Excellent. Now, when we continue with part B, we want to know what happens if we continue with 180 newtons of force on a smooth sidewalk. Let's just redraw the free body diagram. So we're going to have normal, we're going to have weight, and we're just going to have the force of pushing. So what this means, it's supposed to be a P, is it will speed up. And then when we stop pushing, it will now coast at constant velocity, just like in the dry ice lab we did before Christmas break. Now, how hard would we have to keep pushing if the coefficient of friction were only 0.05? So let's do that calculation. That'll be friction equals mu times the normal force. So friction is going to equal 0.05 times 150. So I believe, if I have that right, that should be 7.5 newtons, but I would definitely recommend you go ahead and check that number.